Now that we've talked about chemical compounds, we're going to start combining those chemical compounds through chemical reactions, which involves chemical changes to result in new substances with new chemical bonds that are formed. We're going to rearrange those atoms and produce new molecules. Remember that we cannot create or destroy elements, so the elements that we start with on our reactant, or the left side of our chemical reaction, are going to be the same elements that are on the right side. We are changing the bonds and the connections between those elements. So on the left side are what we call reactants. We show an arrow to represent the chemical change that has happened, and then on the right side there are products. If we want to look at the combustion of methane, methane gas burns in oxygen in order to produce carbon dioxide and water. Combustion reactions, anytime we have a combustion reaction, it is the reaction with molecular oxygen, which is O2, to produce carbon dioxide and water if we have a complete combustion. So the way that we read this is like a sentence. The way that we read it is one molecule of CH4 gas combines with one molecule of oxygen gas to make one molecule of carbon dioxide gas and one molecule of water in the gas form. So that is what this shorthand notation, our chemical reaction, is telling us. Now we have a bit of a problem with this with the way that this is written. And if you look at this drawn out as the molecules, you may notice that we have more oxygen on the product side than we do on the reactant side. We also have less hydrogen. So this is not the chemical reaction that is happening. What do we have to do to change this to make it a proper chemical reaction? We're making a wrong assumption. The assumption we made is that there's one of each of these molecules. So we're assuming that we're combining one molecule of methane, one molecule of oxygen, and producing one molecule of each of the products. This is an incorrect assumption. We need to balance this chemical reaction. When we balance a chemical reaction, we change the coefficients to adjust the numbers of molecules so that the same amount of elements are on the reactant side as on the product side. For this particular chemical reaction, we needed to add a 2 in front of our oxygen and a 2 in front of the water to make our reaction balance. Now if we look at the molecules, we can see that we have equal amounts on each side. The amount of carbon, hydrogen, and oxygen are equal on either side of the arrow. We call this a balanced chemical reaction. Now, in order to balance it, we do have to add coefficients. So we have to add numbers in front of the chemical reaction. We cannot change the subscripts because that changes the type of molecules in the reaction. So we gain a lot of information by looking at these chemical equations. It tells us what the reactants are. If it's on the left side, it's a reactant. If it's on the right side, it's a product. We also get information about the types of molecules that are undergoing our chemical reaction and the products that are produced. We have information about the phases that the compounds are in, and the coefficients tell us the number of molecules or moles that are reacting in order to produce, in order for this reaction to occur. We do have many symbols that we use for chemical equations to give us additional information. So if we want to represent the state of matter, we can use a G, an L, or an S to represent gas, liquid, or solid. We can use AQ, which we've seen before when we were talking about acids, and this means that it is dissolved into water in order to be present for our chemical reaction. Many of our chemical reactions happen in water. We also can have energy symbols, and those are found above the arrow for our chemical reactions, and they give us information about the chemical change that needs to happen or needs to be present in order for the reaction to happen. So one of those, a delta, means that we have to heat our reaction up. H nu, and we'll learn more about why it's H nu in later chapters, but that is the addition of light in order to initiate our chemical reaction. We can have shock or electrical energy added. Another one that you might see is the word cat, which stands for catalyst. Or you might see a different element or compound. So sometimes you'll see it as gold if it's a gold catalyst, or platinum if it's a platinum catalyst, and that's above the arrow. It doesn't participate in the chemical reaction, or it doesn't get used up in the chemical reaction, so it's not in the equation, but if we put it above the arrow, that means it needs to be present in order for the reaction to happen. So let's try to balance a chemical reaction. We're going to write the balanced chemical equation for the combustion of butane. So butane has 4 carbons, all singly bonded together. Its formula is C4H10. So butane is going to be one of our reactants on the left-hand side. This is a liquid at room temperature. We know that if it's a combustion reaction, we're going to add oxygen as a gas. And the products that we're going to get, because it's a combustion, are carbon dioxide as a gas and water as a gas. Now we have to balance this reaction, and this does take some practice. So I usually start with the most complicated thing in the chemical reaction. So in this case, it would be our butane. We leave any elements that are just by themselves, like our oxygen, till last, because they're the easiest to change. So our butane has 4 carbons. That means that we need 4 carbons on the right-hand side. In order to get 4 carbons on the right-hand side, we're going to put a 4 as a coefficient in front of our carbon dioxide. Now we have 4 carbons on the right side and 4 carbons on the left side. If we look at our hydrogen, we have 10 on the left side and 2 on the right side. So in order to balance our hydrogens, we need to add a 5 in front of our water, because 5 times 2 gives us 10 hydrogens. 10 on the left, 10 on the right. So now we have our carbon and our hydrogens balanced. Let's look at our oxygens. So on the right-hand side, we have 4 times 2, which gives us 8 oxygen from our carbon dioxide, and we have 5 times 1, which gives us 5 oxygen from our water, for a total of 13 oxygen. So now, in order to balance our oxygen, we are going to have to add a coefficient in front of our oxygen. In order to make it balanced, because there's 2 oxygen, we need to add 13 halves, because each oxygen is diatomic. So if we add 13 halves of oxygen, that will give us 13 oxygens. Now we're not quite done yet, because we cannot have fractions in our chemical reaction. So in order to get rid of the fraction, we are going to multiply the entire chemical reaction. All of the coefficients are going to be multiplied by 2 to get rid of that denominator. So our new chemical reaction, or our balanced chemical reaction, is going to be 2 of our butane plus 13 oxygen gives us 8 carbon dioxide and 10 water. If we double check, and the best part about chemical reactions is we can tell if we're right by checking to make sure that everything balances. So on the left-hand side, we have 2 times 4 carbon, which is 8. On the right-hand side, we have 8 times 1, which is 8. Our hydrogen, on the left-hand side, we have 2 times 10, which is 20 hydrogen. On the right-hand side, we have 10 times 2, which is 20. Finally, our oxygen, we have 13 times 2, which is 26 oxygen. On the right-hand side, we have 8 times 2, which is 16, plus 10 times 1, which is 10 oxygen. So we know that we've properly balanced our chemical reaction because all of our elements balance. Here's a practice for you to try. Take the compounds and write them into their chemical formulas and balance the chemical reaction. Aluminum is Al because this is an element, so it is just 1 aluminum. Oxygen is a diatomic element, so we need to put O2. Aluminum oxide, so aluminum is a +3, oxygen is a -2. So aluminum oxide would be Al2O3, and the problem states that it's a solid. Now to balance our reaction, I'm going to start with the more complicated compound, which is our aluminum oxide. I see there are 2 aluminums. So to balance that, I'm going to put a 2 in front of the aluminum. Our oxygen, we have 3 on the right side and 2 on the left. In order to balance this, I am going to add a 3 halves in front of our oxygen. Now, because we have a fraction, we are going to have to multiply the entire reaction by 2 to get rid of the fraction. This leaves us with 4 aluminums plus 3 oxygen gives us 2 aluminum oxide. If we check our reaction, we have 4 aluminum on the left, and we have 2 times 2, or 4 aluminum on the right. We have, for oxygen, we have 3 times 2, which is 6 oxygen on the left. We have 2 times 3, which is 6 oxygen on the right. So our reaction is balanced. Here's another practice for you. Pause the video and balance the reaction. Acetic acid is, we know that the cation is hydrogen and acetate is C2H3O2 minus. So our acetic acid would be HC2H3O2, and because it's an acid, it would be aqueous. This reacts with metallic aluminum, which is a solid, and it doesn't matter which order we write the reactants in as long as they're on the reactant side. We make aluminum acetate. So aluminum is a +3, our acetate's a -1. So it's going to take 3 acetate to balance the charge of the aluminum, plus gaseous hydrogen. And this is aqueous, so we need our state in there, plus gaseous hydrogen. Hydrogen is a diatomic gas again. In this case, we're going to balance our reaction. We're going to start with the most complicated part. So the most complicated part is our aluminum acetate. We're going to balance that acetate, so the C2H3O2, as one group. You can think of it like X. Because it doesn't change from the left side to the right side, we're going to keep it all together as one group to make the balancing easier. So we have 3 acetate on the right. In order to gain 3 acetate on the left, we're going to have to put a 3 in front of our acetic acid. We have 1 aluminum, so we're good there. Now if we go to balance our hydrogen, we're not worried about the hydrogen in the acetate. We are only looking at the hydrogen at the beginning, so the H from our acid and the H2. Because we have 3 hydrogen on the left and 2 on the right, we are going to have to put a 3 halves in front of our hydrogen. Now because we have a fraction, we're going to have to multiply the entire reaction by 2. This results in 2 aluminum plus 6 acetic acid gives us 2 aluminum acetate plus 3 hydrogen. You can check to make sure this balances by counting all our elements. So our aluminum, there are 2 on the left, 2 on the right. Our hydrogen, we have 6 from the hydrogen in the front of our acetic acid, and 6 times 3, which is 18, from the acetate. If we look on the right-hand side, we have 3 acetates, so 3 times 3 is 9, times 2 is 18, plus 3 times 2 from our hydrogen, which is 6, so our hydrogen balance. Our oxygen, we have 6 times 2, which is 12, 6 from the coefficient, 2 from the acetate, And if we look on the right hand side, we have 3 times 2, which is 6, times 2, because there's 2 aluminum acetates, which gives us 12. So our reaction balances. This does take some practice. So if you would like additional practice, you recommend looking at the problems in the back of the book.